Hello everyone, this is Nirali Patel from New RJ Institute of Engineering and Technology. In today's lecture, we are going to discuss about measure of statistics for group data and for ungrouped data. So let's first discuss about what is the group data and ungrouped data. So ungrouped data, that means you are given with individual observations like suppose x is equals to 2, 3, 5, 7, 8, 7, 6. So this is nothing but the example for the ungrouped data. Now, what is the group data? So, group data is further divided into discrete series and the continuous series. In discrete series, you have a observations and the frequency of observations. Like observations are 2, 3, 4, 5, and suppose 2 are 5 times, so the frequency of 2 is 5, 3 is 4 times, so that is 4, 4 is 2 times, so that is 2, 5 is 1 time, so frequency of that is 5. And in continuous series, you are given with the class interval like the 0 to 10, 10 to 20, like that. So 0 to 10, 20 to 20, 20 to 30, and frequency is given like 5, 4, 3. Okay, so here I'm giving you simple example. So this is nothing but the example for the exclusive series, because the whatever the first class interval ending with the 10, so second class interval will start with the 10. The example for the inclusive series you can consider like that class and frequency f. So that is like 2 to 4, then 5 to 7 to 3 is the respective frequency of this particular class. So this is the exclusive series and this is the inclusive series. So this is nothing but basic introduction to different types of data. Now let's see the different measure of statistics for this different type of data. So first is the mean. So as we have already discussed that mean is nothing but that is the average value. So for ungrouped data, mean is given by x bar is equals to sigma x upon small n, where small n is nothing but the number of observations. So here I have taken two examples to calculate the mean of this individual observation. So ungrouped data is also known as individual observations. So the first example is 4, 8, 7, 15, 80 and 20. So this individual observation is given. So x bar is nothing but sigma x upon n. So that is 4 plus 8 plus 7 plus 15 plus 18 plus 20 divided by n. Then that is nothing but number of observation, that is the 6. So 72 by 6, which is equals to 12. Now see, over here the same data is given but extra observation is 0. So here to calculate the mean we have to consider that observation. We can't neglect the 0 in the observation. So that is equals to 4 plus 8 plus 7 plus 15 plus 18 plus 20 plus 0. Now the number of observations are 7. So that is equals to 72 by 7. So that is the mean for this example. Now moving to the next. So if you are given with the simple frequency distribution, that means the discrete series like this. So for that case, the mean is find out through the two method, direct method and the assume mean method. So the formula for direct method is x bar is equals to sigma fx upon n, where n is nothing but sigma f. So sigma fx upon sigma f. And assume mean method is x bar is equals to sigma fd upon capital N, and that is equals to sigma fd upon sigma f. Now what is the d? So d is nothing but the deviation. So that is the deviation of observation from the assumed mean, where a is nothing but the assumed mean. So you can take any value as an assumed mean. So let's understand through this concept for the example. So the first is that for the direct method, so x is 7, 11, 15, 10 and 12 and the f is also given 2, 3, 6, 4 and 3. So here the formula for calculating mean is sigma fx divided by capital N, which is nothing but equal to sigma f. So we can calculate the sigma f through the 2 plus 3 plus 6 plus 4 plus 3, which is equals to 80. Now, to calculate the mean, we require the sigma fx as well. So first, let's find out the x into f. So that is nothing but 40, 33, 90, 40, 36. So sigma fx or sigma x into f is equals to 213. So now we have to just put the value over here. So 213 divided by 80. So the mean is equals to 11.83. So this is the direct method. Now let's understand the example through the assume mean method. So here the x and f is given. So let's just write down the observation that is given over here. And the value of f is 3, 2, 7, 5 and 2. So as we have discussed, we can calculate the mean for through the assume mean method, that is equals to sigma fd divided by capital N, where d is equals to x minus a and the a is the assuming. So let's take the value of a is nothing but the 15. So 10 minus 15, that is minus 5, 12 minus 15, that is minus 3, 0, 18 minus 15, that is the 3 and 22 minus 15, that is equals to 7. Now we require the sigma fd. So for that we have to calculate the f into d. So minus 5 into 3, that is minus 15, minus 3 into 2, that is minus 6, this is equals to 0, 5 into 3, 15 and 2 into 7, 14. So sigma fd is equals to 8. So we can just put the value over here. X bar is equals to 8 upon sigma f, where sigma f is equals to 90. So that is equals to 8 by 90. That's why x bar is nothing but 15.42. So here, if you solve this example through the direct method, you will get the same answer 15.42. But here we make use of the assume mean method to make the calculation easy. Now let's understand the mean for the group frequency distribution. So that is nothing but the continuous series. So the first method is the direct method to calculate the mean, that is x bar is equals to sigma fx upon sigma f. This is the same formula that we have discussed for the discrete series. Next is the step deviation method. So in that case, x bar is equals to a plus sigma fd upon sigma f into h. So this is the method for the calculating the mean. Now let's understand the example for the direct method and the step deviation method. So over here the class and frequency is given. Now the formula is x bar is equals to sigma fx upon sigma f. Now here we don't have the value of x. So first we have to calculate the value of x. X is nothing but that is the midpoint of the class interval. So 0 plus 10 divided by 2, that is the 5. 10 plus 20 divided by 2, that is 50, 25, 35 and 45. Now we have to calculate the f into x. So that is the 15, 75, 100, 280 and 90. So sigma fx is equals to 560 and sigma f is equals to 22. So that is equals to x bar is equals to 560 divided by 22, which is equals to 25.45. Now moving to the next example. So this is the same example that we have discussed through the direct method. Now we are going to discuss through the step deviation method. So now the formula for the step deviation method is x bar is equals to a plus sigma fd upon sigma f into h. Now over here h is nothing but the width of the class interval. So 10 minus 0, that is the 10. 20 minus 10, that is the 10. So 8 is equals to 10. A is the assumed mean. Now, in order to find out the assumed mean, first we have to find out the value of x. So x is nothing but that is the midpoint of the class interval that we have discussed in the previous example. So that is nothing but 5, 15, 25, 35 and 45. Now let's take the value of a is 25. Now d is x minus a by h, where h is class interval width, that is the 10. So 5 minus 25 divided by h, that is the minus 2, minus 1, 0, 1 and 2. Now let's find out the f into d. So that is the minus 6, minus 5, 0, 8 and 4. So sigma fd is nothing but that is the 1 and sigma f is equals to 22. So let's just put the value over here. 25 plus 22 divided by 1 divided by 22 into 10. So the answer is nothing but that must be equal to 25.45, because if you solve the example through the direct method or the step division method, you are going to get the same answer. Now moving to the next topic, that is the combined mean. So suppose if you are given with the n number of groups, or let's consider the m number of groups. So this is the first group, this is the second group, this is the m group. Okay. So for the first group, the x bar is given and the value of n is given. That is nothing but the number of elements. For second group also the x bar is given and the number of elements of the second group is given. And for the m group, the x bar is given and the number of elements in the m group is given. Now, if you want to find out the mean of this all group, so that is nothing but the combined mean. So that is given by x bar equal to x1 bar n1. Let's consider this as x1 bar n1. This is as x2 bar n2, and this is xn bar nm plus x2 bar n2 and up to xn bar nm and divided by n1 plus n2 up to number of elements in the n group. So this is the combined mean method. When we can use this combined mean method? So suppose if you are given with the result of the class 10 for division A and result of class 10 of division B, and the x bar for division A is given and the number of elements in division A is given. The x bar of division B is given, that means the average result of B class, and the number of students in the B class is given. Now suppose xa bar is suppose 85 and na is equal to suppose 50, and similarly nb is 50 and xb is 86. Now suppose if you want to calculate the average result of 100 students, that means the result of division A and division B combined, that is the average result of division A and division B combined. So that time we can make use of this combined mean method. Now moving to the next topic, that is the geometric mean. So we have already discussed about what is the geometric mean and all of that. Now let's discuss about the geometric mean for the individual observation. So if you are given with the individual observation x1, x2 up to xn, so geometric mean is equals to x1 into x2 up to xn whole raised to 1 by n, where small n is nothing but the number of observations. So we can take the log both sides. So log gm, that is the geometric mean, is equals to 1 by n log x1 plus log x2 plus up to log xn. So we can get the value of geometric mean by taking the anti-log both sides. Now, if you are given with the discrete series, so in that case, the value of GM is x1 raised to f1 into x2 raised to f2 up to xn raised to fn whole divided by whole raised to 1 divided by capital N, where capital N is nothing but the sigma f. So by taking the log gm, so that is equals to 1 by sigma f or 1 by capital N f1 into log x1 plus f2 into log x2 plus up to fn into log xn. Now, if you are given with the continuous series, so first you have to find the value of x and then you can apply this same formula. Now moving to the harmonic mean. So the harmonic mean for the individual observation is given by 1 by h is equals to sigma 1 by x whole divided by n. So we can write h is equals to n divided by sigma 1 by x. Now, this is for the individual observation. Suppose if you are given with the discrete series, so in that case, h is equals to sigma f whole divided by sigma f by x. And if you are given with the continuous series, so you can find the midpoint, that is nothing but the x. You can apply this same formula. Now, harmonic mean is sometimes also written as hm. So this is all about the harmonic mean. So this is all about the mean. In next lecture, we are going to start with the median. Till then, keep exploring and thank you.